Good morning. Let's see. So we're going to continue our study of hypothesis testing. And now we're looking at hypothesis testing for proportions. We have one objective, and it is to determine or to learn how to use the z-test to test a population proportion P. Now I have written here the two different methods. Again, we've got the, both of these are for doing a one proportion hypothesis test. Let me put it in here, but that's what these guidelines are for. A one proportion hypothesis test. And the two different methods are essentially using critical values, which is in green here, critical values. And the other method is using p-values. And this is on the calculator. Okay. So now on the calculator, the test that you're going to use is one prop z-test. And so you're going to go to stats and then go over to, perhaps I should be doing this in a different color, but stats, and then you're going to go to tests, and then you'll see one prop z-test. Okay. So for instance, on my TI-84, which is I think an older version of the TI-84, if I go to stat test, one prop z-test for me is number 5. Okay. Overall, the procedure is the same. You start by verifying that you can actually perform the test. We're no longer doing the t-test. You're just performing the test. Now here, how do you verify? Because we are doing we're working with proportions, we need to guarantee that NP and NQ are large enough to make our binomial distribution approximately a normal distribution. And the ratios that work are n times p is greater than or equal to 5 and n times q is greater than or equal to 5. So if both of those are greater than or equal to 5, then it's reasonable to approximate the binomial distribution with the normal distribution. And then, of course, as always, we need to verify that our sample is random. And so that's true regardless of which method you're using. The second step is your setup. You've got to set up your null and alternative hypotheses. Third step, which is the easy step, is you've got to figure out alpha. And then the fourth step, if you're doing the critical value method, is you've got to use your alternative hypothesis to figure out whether you're performing a left-tailed, right-tailed, or two-tailed test. And then you've got to get your critical values, and that combined with whether you're doing left-tailed, right-tailed, or two-tailed will give you your rejection regions. Last thing is you need to determine your standardized test statistic. We'll give the formula for the standardized test statistic in just a second, but as a preview, it is going to be z equals p hat minus p over your standard error, which in this case is the square root of PQ over N. Okay, so we'll do an example. We'll do two examples in this section. One example will involve using the critical value method, and the other example will involve using the p-value method. So we'll get a chance to practice computing this standardized test statistic. You'll make a decision based on whether your test statistic is in your rejection region or not. And then lastly, you'll interpret your decision based on whether or not your claim is H0 or HA, and whether or not your decision was to reject or fail to reject your null hypothesis. And on the other side here, it's very, very similar, right? Step one, you've got to verify that you can perform the test. Then you have to determine your null and alternative hypotheses and alpha. And then the next thing is you're going to use one prop z-test on your calculator, and we'll see exactly what's needed for there. After that, you'll make a decision, and lastly, interpret your decision. Okay, so let's get to it here. Now here we've got written again the, let me highlight this actually, because this is quite helpful. So the test statistic is going to be your sample proportion p hat. Okay, so this is very similar to the point estimate from confidence intervals, right? What are you going to use as your test statistic? You're going to use p hat, and that is going to be the proportion for the sample. Okay, for the sample. And then below here we've got the standardized test statistic, the formula for it. You can notice here that, like we said, we're trying to approximate our binomial distribution by a normal distribution. So what we're essentially doing, let me take it back, is remember with the binomial distribution, you have, these chunky little finite histogram, right? You've got these chunky little rectangles, and under certain conditions, it would be, your distribution would be symmetric. You're going to approximate it, and you're going to say, oh, it's very similar to a normal distribution, right? So when we are looking for the standardized test statistic, it is going to be our usual value of z is equal to the value minus the mean of the sample distributions over the standard error. Okay, so that's where we get this formula from. And remember, this formula for standard error of your sampling distribution is going to be sigma over square root of n. But when you have a binomial distribution, the standard deviation is the square root of NP. Okay, remember standard deviation and the variance is the square root of NPQ. So we're using those formulas to come up with the formula for the square root of PQ over N for our denominator. Okay, so we don't need to go over these because this is kind of a rewording of the guidelines that I put in the beginning. Let's go ahead and get started with this example. So take a moment and read it. Okay, so looking through, the first thing I want to do is identify the phrases, or identify the keywords and the key phrases that stand out. So the first one is this part right here: claims that less than 50% of U.S. adults have access to the internet over a wireless network with a laptop computer. So this is giving me my claim, right? So claims, it's too light. Let me do a different color. Claims that less than 50% of U.S. adults have access to the internet over a wireless network with a laptop computer. Okay, in a random sample of 100 adults, that's important because that's telling me my sample size. 39% say they have access to the internet over a wireless network. That's important. That's giving me my p hat. At alpha equals 0.01, that's important. Is there enough evidence to support the researcher's claim? Okay, so let's go ahead and start going through our guidelines here. The first thing we want to do is verify that you can perform the t-test. Number one, you want to verify that NP is greater than or equal to 5 and NQ is greater than or equal to 5. Number two, you want to verify that your sample is random. So let's go back here. And, in fact, I'm going to clear this so each time I can highlight what we're using. So, in a random sample, so we can verify that, yes, verify that the sample is random. We say, yes, this is stated in the problem. Okay, stated in the word problem. Now verify that NP and NQ are greater than or equal to 5. I need to know N, and I need to know P, and I need to know Q. My N is going to come from this number right here because my sample size is 100 adults. So N is equal to 100. My P, the P that I'm going to use is this top P right here. So this 50%. This is my P. And if P is 50%, then Q has to be 50% because Q is 1 minus P. So let's go over here and we can write down that my N is equal to 100 and my P is 50%, which is the same thing as 0.50. And my Q, which is 1 minus P, is going to be 1 minus 0.5, which is also going to be 0.5. And now I need to check what is NP. Is it greater than or equal to 5? And how about NQ? Is that greater than or equal to 5? Well, now NP is, so that's going to be 100, and the P is going to be 0.5. So when I multiply those together, I'm going to get 50, right? So this NP is equal to 50, and I've got the same numbers for NQ. So I can conclude, thank you, I can conclude that 50 is greater than or equal to 5. So yes, from these computations here, yes, NP is greater than or equal to 5, and NQ is greater than or equal to 5. Now, determine your H naught and your HA. Write down the claim using everyday English words. Let's see here. What is my claim? The claim is, so a research center claims that less than 50% of U.S. adults have access to the computer or internet over a wireless network with a laptop computer. So this is a lot to write down, so I'm going to kind of simplify it, truncate it into less than 50%. Less than 50% of adults have accessed internet. Okay, translate into math. So in this case, P, my proportion is representing, P is representing the proportion of U.S. adults that have accessed the internet, right? So P is the percentage of, or the proportion of U.S. adults who have accessed the internet over a wireless network with a laptop computer. Okay, so if my claim is that less than 50% of adults have accessed the internet, then translating this into math, I would get that P is less than 50%. And I can also write that as P is less than 0.5. Okay, so let me in fact write it in terms of that. P is less than 0.5. P is less than 0.5. Write the complement. The complement is going to be P is greater than or equal to 0.5. Now to figure out which one is H naught and HA. So H naught is going to be the H naught is going to be the statement with the equality symbol. So the P greater than or equal to 0.5. And HA is going to be the other statement, P less than 0.5. And our claim is P less than 0.5. So our claim is actually the alternative hypothesis. Okay, determine alpha. Alpha from the problem is 0.01%. And that's just right here, 0.01. And then to determine your critical values and rejection regions. Now, to get my critical value, the first thing I need to do is I need to figure out if I'm using a left-tailed test right-tailed test or two-tailed test. Now I've got a z distribution, so I sketch that. And looking at my alternative hypothesis, I am going to have a left-tailed distribution simply because my statement is that p is less than 0.5. So if I know I'm going to have a left-tailed test, then let's see here. So I've got some version like this, right? So my critical value would be ZC. This area is alpha, which is going to be 0.01. And in order to find ZC, I need to use inverse norm. My cumulative area is going to be 0.01. And my, what do I need? Let's see here for inverse norm. I think I need my mean and my standard deviation. So let's go to second, vars, inverse norm. That's number 3 for me. My area is 0.01. My mu is 0 because this is the standard normal distribution. So this is my mu. This is my cumulative area. And my sigma is going to be 1. Okay. And I hit paste. And what do I get? I get negative 2.3. Negative 2.3263. So that is my critical value. And my critical region is anything whoa, that's too big. So let me undo that. So I want to say that my critical region, I'm trying to indicate that my critical region is any value that is less than negative 2.3263. So my rejection region is any value less than negative 2.3263. All right. So I've got my critical values in my rejection region. Next thing is to determine my standardized test statistic. And the formula for that is Z equals P hat minus P divided by the square root of PQ over N. So I want the square root of that. Now my P hat is going to be 0.39. How did I get that? I get the P hat from the statement. 39% say they have accessed the internet, so 39% of my sample has been successful, right? So my P hat is going to be 0.39. The P that I use is 0.5, right? So this is the value that I put in here. So this is the hypothesized P. So that's going to be 0.5. And now, again, we'll have P is 0.5. Q is 0.5 because remember P times that Q is 1 minus P. And then over the square root of N, sorry, N is 100. So it needs to be over 100. I need the square root of all of that. When I put it into my calculator, I get let's see, square root of 0.5 times 0.5 divided by 100. So I get negative 2.2. So my standardized test statistic is negative 2.2. Now, to make a decision, reject or fail to reject, I need to see, is negative 2.2 in my rejection region? Now remember, we said our rejection region is any value less than negative 2.3263. So it's kind of like blowing up this z axis. If I've got negative 2.3263, and here's 0, where does negative 2.2 fall, right? It's going to be bigger than negative 2.3. So negative 2.2 right here. So my rejection region, remember, is anything less than. So my decision is going to be fail to reject, H naught, because my standardized test statistic is not in the rejection region. So fail to reject, H naught, is my decision. And then interpret my decision. That's the last one. Let's see here. So to interpret my decision, I need to put together that I failed to reject H naught, and my claim was, what was my claim? My claim was HA, right? So since my claim was HA, both of those together, according to the interpretation rubric, means that means that there's not enough evidence to support the claim. So my interpretation is as follows. So I would say at the 1% significance level, there is not enough evidence to support the claim that less than 50% of adults, of U.S. adults, access the internet, over a wireless network, blah, 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 with a laptop. Because remember, that was the full claim in its long drawn out glory, is less than 50% of U.S. adults have access to the internet over wireless and network with a laptop computer. Okay. All right. So that is that problem. Now, let's go to the next problem here. So the research center claims that 25% of college graduates think a college degree is not worth the cost. So already the claim is that 25% of college graduates think a college degree is not worth the cost. Ooh, I wonder where they went. So we can start to actually write down our claim. What is the claim? 25% of college graduates think degree is not worth the cost. Okay, how do I translate that into math? Well, P equals 0.25. Right, so P is the proportion of college graduates, all college graduates that think that the degree is not worth the cost. Now let's write the complement is going to be P is not equal to 0.25. And if I figure out which is my null and which is my alternative, my null hypothesis is going to be the first one. My alternative is going to be the second one. So my claim is actually the null hypothesis. Okay. Now I kind of did that because I'm just reading along and I'm just picking up keywords. You decide to test this claim and ask a random sample of 200 college graduates. Okay, so bam. Already I know that my sample is random. and n is equal to 200. So I'm going to need that in my calculator. N is equal to 200. And I verify that my sample is random. I also need to verify that NP is greater than or equal to 5 and NQ is greater than or equal to 5. At this point, this P is the 25%. So if N is equal to, we said N is equal to 200, and P is equal to 0.25, then Q must be 0.75. And so now I'll say, what's NP? It's going to be 200 times 0.25, which is going to be 50. And now what's NQ is going to be 200 times 0.75, which is going to be 150. So they are both greater than or equal to 5. Okay, so I can use the test. Determine alpha. Reading ahead here, it says that at alpha equals 10%. So I know my alpha is equal to 10%. I can write that as 0.1. And now use one prop z-test on my TI-84. Okay, so here we go. So we go to stat, go over to tests, go to one prop z-test. For me, that's number 5. And here's what it says in my calculator. So it's got the one prop z-test, of course.
It's 21:30.
Thank you. And then it's got P naught, and then it's got X, N, and then it has prop not equal to P naught, less than P naught, greater than P naught, and then calculate, and then draw. Okay, so my P naught, which is my P naught is going to be 0.25 because that is the hypothesized. So it's right there, and it's also right here. So it's the hypothesized proportion, right? The claim, what is the claim, trying to test? It's trying to test around the proportion of 0.25. So I have 0.25 here, 0.25. And now what is my X? Remember, X is supposed to be the number of successes. Now this is key. I don't know. They didn't tell me they didn't tell me the number of successes. Well, let's look here. So it says, of those surveyed, 21% replied yes. So 200 were sampled. So 200 were surveyed, and 21% replied yes. So my X is going to be 21% of 200. And now how do I find that? Now let's translate this. So it'll be 0.21, and of turns into times. Remember? So I need that times 200. And now on my calculator, 200 times 0.21, that should give me 42. Okay, so I've got my X. In here I need to put in 42. And then N needs to be 200. To determine what I select for my alternative hypothesis, let's look back here. It looks like I had P is not equal to. So I'm going to select this first one here, the not equal to button. All right, let's see if we can calculate this. So let's go to tests. Okay, so my X I said is 42, N is 200, and I'm going to use not equal to, hit enter, and then go to calculate, hit enter. And the output was, I'll tell you the output. The output was prop not equal to 0.25. Z equals negative 1.306395. P equals 0.1914185541. And then I have P hat equals 0.21. N equals 200. And of course at the top it says something like 1 prop Z test. And that's kind of shaded in here. Okay. So we went over this, I believe, before. This is your alternative hypothesis. This is your standardized test statistic. This is your p-value. This is your sample proportion. And of course, this is your sample size. So, to make my decision, remember I need to compare p with alpha, and it appears that my p-value, so I need to compare my p-value with alpha. My p-value is 0.19. My alpha is 0.10. So this is pretty high alpha. This is a pretty high p-value. So my decision is going to be to fail to reject H naught. And now to interpret my decision, I need to use the fact that I failed to reject H naught and H naught was my claim. Let's see here. My claim is H naught and I failed to reject H naught. So not enough evidence to support the claim. Wait a minute. Let's see here. Let me just double check here. So if I, because I always forget, if I fail to, let's see here. If I fail to reject H naught and the claim is H naught, there's not enough evidence to reject the claim. Okay. So back here, my decision is not enough evidence to reject the claim. Okay. And now the last thing we want to do is I want to show you just briefly how to fill out this little form here. So state the claim verbally. We did that here. So it'll be this. Copy. Paste. State the claim mathematically. We did that. P equals 0.25. Wait, I think I'm missing something because shouldn't it be? Yeah. Okay, so here we've got P equals 0.25. My null hypothesis, just from writing down what we had, was P equals 0.25. My alternative hypothesis, P is not equal to 0.25. The claim is my null hypothesis. The significance level was 10%. Which test did I use? I used a one-prop z-test. What is the distribution? It is the z distribution. And again, the hint is because, not because, but a hint is that the distribution is in the name. The requirements of the test, we need a random sample. And we need to know that NP is greater than or equal to 5. And NQ is greater than or equal to 5. Okay, and each of these we tested, so we showed how to test them on the other side. Now let's see here. What is the standardized test statistic? Here's where I can go to my output and use this standardized test statistic. Okay, Command copy. So I don't have to do the formula. I don't have to fill out that formula because I already have the I already have that information automatically computed and collected by the calculator. Okay, so here's my p-value. Copy. Paste. my p-value here. And 1 or 2 complete sentences explain what the p-value means for this problem. Here it is. So what it means is the probability of getting a sample obtaining a sample as extreme or more extreme than, and this is a sample proportion. So let me clarify this. A sample proportion as extreme or more extreme than 21%. What is that probability? The probability is, what is our p-value? 19%, right? Because we've got 19.14, 0.1914. Assuming that the population proportion is 0.25. So assuming that the population proportion is 0.25, what's the probability that we would get a sample size that is as extreme or more than 21%? It's like 19%. Okay. Now the last thing here is let us add the standardized test statistic. So our standardized test statistic is negative 1.3. So I'll go right here, put negative 1.3. And in order to determine how to shade, I need to look at my null hypothesis. My alternative hypothesis. From here, I see that I need to do a two-tailed test. Two-tailed test. So the negative 1.3 and the positive 1.3. So these areas, here and here, these areas add up to 0.1914. And I can put here a z to indicate that we're using the z distribution. And then we already know how to put the decision. So the decision was to fail to reject. Why? Because p value was greater than alpha, and to interpret the greater than or equal to alpha, and to interpret the decision in the context of the original claim using complete sentences. I believe we did that already over here. Not enough evidence to reject the claim. So let's see here. So we would say at the 10% significance level, there is not enough evidence to reject the claim that 25% of college grads think a college degree is not worth it. Okay. All right, so that's the end of this video. And we learned how to use a z-test. More specifically on the calculator, we use the one-prop z-test to test a population proportion p. Thanks.